All right, everyone, welcome. Go ahead. It's time to take your seats. Let's go ahead and get started, shall we? Today's class is going to be all about OpenTelemetry, but we've got to lay some groundwork first, so I need everyone's attention. We're going to start by talking about observability and traditional monitoring data, and then how that feeds into OTel. The goal of the class today is to provide you with sufficient information so you can have meaningful conversations with your IT, management, developers, and everyone else, so that when observability becomes critical to your organization, you can be a part of those discussions. I don't want anyone here left behind if you get stuck with traditional monitoring. You need to think about observability solutions. And part of that is OpenTelemetry. In previous classes, we discussed why IT should not be operating in silos. Your network team should be talking with your servers team, should be talking with your applications team, and storage, and everything else. Because end user problems, be they internal or external to your organization, are not a server problem or an app problem. It's an all of IT problem. Historically, developers have not been included in this discussion, but that needs to change. They are in their own silo. They are realistically, in a lot of organizations, they're treated like they're on a desert island. And whenever there's a problem, someone in IT writes a little note, sticks it in a bottle, and throws it in the ocean and hopes the developers get it. The problem with that is that a majority of the IT personnel may not understand what the code is meant to do. They don't know what it was fixing. They don't know what new features were added to it. They don't know the purpose of it from a business venture. And because of that, they're coming at it from a completely outside view. We cannot work that way. Developers is another silo that we just haven't discussed yet, but that needs to change today. Today's IT experiences are about the end users. Your internal users, external users, ones from the internet, anyone that consumes some type of data about your business, that should be your priority. Not that your servers are okay or your network gear is playing nice. It should be about the end user's experience. And that's why we need to move from monitoring data to observability data. And we will get much more detailed about that, but I just want to set the stage. A phrase that's been floating around the industry for a little while is DevOps, the implementation of developers with ops teams. What I want everyone here to be aware of is that DevOps is not another silo. It is a workplace methodology. It is a way that you have developers working with the IT ops people in lockstep. That way, when a problem occurs, and they will occur, this is IT after all, you have everyone together at one time who can solve that problem. DevOps is not a specific job title. It is not a new team in most organizations. It is a restructuring of the way you handle the work that is given to you and your team. Before we go much further, I really want to define the difference between monitoring data and observability data.
Mr. Sparrenberg, isn't observability the same thing as monitoring?
Oh, me from the past, how myopic we were. No, it is not just a new industry buzzword. It is a complete change in the way we work with the information. One feeds into the other and is part of it, but they are distinct, and that's why we're having these discussions. If we talk about observability and traditional monitoring data, they aren't a Boolean and, they aren't a Boolean or. What they are is one is a subset of the other. Traditional monitoring data is a subset of observability. Observability is an enhancement layer on top of your traditional monitoring data. This is as good a time as any to recap what we mean by monitoring data. And for that, it really comes in two flavors. And the first one of those is KPIs, some type of number or status that comes back from a system that is being monitored. Something like CPU or memory consumption or volume space used, something in that realm. And then also for the applications that run on those elements, how much CPU is being used by this process, what number of transactions are going through, how many database calls are being made. All of those things are available in traditional monitoring. And we want to make sure that that is part of our larger discussion. And you'll see how those two tie together. Additionally, we're going to get logs. Logs come from all manner of things. They come from your network gear, they're going to come from your applications, the servers, and they all get aggregated together and interlinked with that KPI data And good monitoring solutions will show you all of this in a really nice time slice so you can see how one affects the other and vice versa. Observability data differs from monitoring data in a couple of very specific ways. And for that, we're going to actually go back to the definition of observability data. True observability data is made up of three sides of a triangle: metrics, logs, traces. I guess it's time for a vocab lesson. And I'm not going to make you write it 100 times and then use it in a sentence, except for me from the past. You have to do that. Metrics is a word that we have used over and over again in the industry for 20 plus years, and it fundamentally means the same thing. Observability data strictly defines what it means by a metric, though. A metric has to be made up of at least 2 parts and up to 4 parts. Those 2 parts are the number or string itself, and then the kind. Basically, what is it? What is it about? Is it a counter? Is it an up-down counter? Is it some type of aggregate? So that we have kind of a better understanding of the number we're coming back to. Additionally, metrics and observability also can include a unit, so stuff we typically deal with, bytes, bits per second, or if it's just a count, and also a written description, a long string that defines what we're looking at. So this is where we talk about taking the original KPI information we had from our traditional monitoring and enhancing it. So we went from KPIs to metrics. One of the things that frequently causes confusion when people move from traditional monitoring data to observability data is that metrics have a very specific naming scheme. And it's not difficult to understand if you have any background in object-oriented programming. In fact, if you look at a couple of these names here, you can see very easily that it makes sense. You can see this first one says HTTP server, request, duration. It's pretty obvious that that is how long the web server took to do something. Similarly, all metrics are done in this dot notation. This is for a couple of reasons, but number one, it's for ease of readability. Just by looking at the individual segments, you understand the top level, more precision, more precision. Finally, this is the exact thing I'm looking at. Logs are the closest to what we've dealt with from traditional monitoring. In observability data, there's only a couple things that need to be added. The source of them must be required. We need to know where the logs come from, and they need to be in such a format that they can be converted to and converted back from alternate formats. We're not going to get into the specifics of that. It's not important for your knowledge. Just understand that the logs are the same kind of logs you've been collecting in traditional monitoring for years now. If you're coming from traditional monitoring, tracing or distributive tracing may be a completely new concept to you. So we're going to take a little bit of time later to break it down. But what you need to understand right now is it is a way to watch workflows as they move throughout your systems and record information about it. We will have a much more detailed description a little later. But those make up the 3 parts of observability data: metrics, logs, traces. You can easily see why we consider monitoring data a subset of observability data. Monitoring data provides you the numbers and the logs, but the observability data takes it and enhances it by streamlining the metrics, giving them better names, organizing the logs in a better format, and providing these distributed traces. If you take nothing, and I mean nothing else from this class, the one thing you need to remember is although monitoring data is good, observability is far superior. Got it? All right, let's move on. I'm looking around and I'm seeing a lot of confused faces. And you're probably thinking the same thing I did when I started down this track. Why do we even need observability data? And realistically, for certain organizations, it's not necessary. It's very good. It helps them troubleshoot things. But if you are only worried about a specific thing, if we take this cup and I want to make sure this cup has the number of pens and it is the right color and those things like that, it's fine. Traditional monitoring will get me all of that. Those are just KPIs about the mug. The trick is, what happens if this mug is part of something a little more ephemeral, a little ethereal, where it actually represents a service like a website, where as the load increases, we have to spin up another copy of this mug, and then another copy, and another copy, and another copy, just to handle the load, the workload of everything coming in at that time of year, or for a specific sale, or what have you. The problem with traditional monitoring is you have to point it at a thing. The beauty of observability data is that you just need to know that thing exists and how to talk to the idea of it, which is why a lot of times we will talk about services that we are monitoring with observability data as opposed to servers we're monitoring. If you deal with auto-scaling groups like that, you will never, ever be fast enough to add them all to a monitoring solution. This is why we need an observability solution that works fundamentally differently. And although it cares about those particular KPIs and those metrics, that's not the most important story. The most important story is how your end users are interacting with these systems. Unlike a traditional monitoring solution, which is very pool-centric, I go out to a machine, I pull SNMP, I go out to a machine, I pull KPIs from WMI, I go out, I make a call against an API, I get information back. Observability is much more push-centric. Essentially, the elements in your service stacks will take information and send them to an observability collector, which then does whatever processes it needs to and ships it off to a solution. Because it is a push mechanism, we don't need to actually touch each of the elements individually. As long as they are configured from start to know about this collector, as new ones spin up and new instances are built, they will automatically start shipping that data to the observability collector. I mentioned at the top of this class OpenTelemetry, and we're going to get back to it now. We've spent a lot of time going over traditional monitoring and observability data. What you need to understand about OpenTelemetry is a framework for collecting, transforming, and shipping observability data to a backend. And as a concept, this is not revolutionary. There are many traditional monitoring solutions that work like proxies, where they will collect stuff from a local area, bundle up, and ship it off to another location for processing. What's really interesting and what I find incredibly revolutionary about OpenTelemetry is that it's been adopted by pretty much everyone. And anyone who's been in the industry for a while knows that IT companies generally can't decide on any one thing. They all have to have their own. And what makes OpenTelemetry so interesting is that all the big players have all decided to adopt this framework so that they can ship their observability data in the same way using OpenTelemetry over and over again. It makes it easier for them, it makes it easier for the developers, it's going to make it easier for you because every system will be able to handle this kind of work. What does OTel actually look like? This is an example of an online storefront. This diagram is made up of multiple interconnected services where you can export observability data into a system capable of receiving OTel formatted information. This is typical of similar systems, both in terms of scale and complexity. Although the example we're looking at here is an online storefront, most systems have this level of scale and complexity when you really dig into them. Before we get started on that, let's look at what you could get if we stuck with traditional monitoring. For the sake of this example, let's assume everything is a single service running on a single server. If you wanted information from the system, you would point a monitoring solution at each of the servers and ask them for basic information like CPU, memory, and volume information. Finally, you'd retrieve performance counters from the services themselves, representing interesting data from each and every one of them. To round out the monitoring data, you would also pull logs from both the service and the servers underneath of them. So you'll have interesting data about the way the applications are working and also about the underlying health of the server. But what happens if the connection to and from the cart service starts slowing down? Mind you, it doesn't go down, it doesn't stop. It just gets progressively slower and slower and slower. The trick here with traditional monitoring data is that down is easy. You can't get to something, you're getting numbers that are zeros, their CPU's at 100%, whatever. Down is easy. This thing isn't working. Slow is hard. It's much more nebulous. And without having an incredible amount of detail about it, like the stuff we get from observability data, it's really hard to see why something is slow using just traditional monitoring. If the duration it takes to access this service continues to grow slowly but steadily, there's a very real chance traditional monitoring will not be able to pick this out as a culprit for being slow. Now, if we take this same diagram of services and take what we've learned and apply observability data to it, you're going to see a drastic difference here. For starters, tracing would be enabled at each service. This is a good time to talk about what actually a trace is. The traces, and sometimes called distributed tracing, will give you details about the path of data among each service and how it's processed as it works its way through the system. From a conceptual perspective, I like to think of each unit of work, known as a span, as a page, and the trace itself as a book that tells the story of that entire workflow. When you enter the front-end proxy, OTel generates a unique trace ID. In this case, we can think of it as our book title, used for record keeping through the whole process, and a span ID, I think of it as a page number, for the work being done by this proxy. Whatever relevant details are necessary about the front-end proxy are also included in this span. Some pages in our books will have more densely packed information than others. Then that information is passed along to the front-end service, keeping the same trace ID, which becomes yet another page in the story with a new span ID. The process repeats for all the remaining services until a complete book is assembled and the trace is closed. Now, the book analogy is a real simplification of the process, but I wanted to give you the concept, kind of the framework around it, so we can continue the discussion. Since the start and end time of every unit of work is always recorded, we know exactly how long it took each transaction to complete. This means we can flip through our book and know exactly how long it took for the front-end proxy to forward the work to the front-end service, how long it took for the catalog to load, how long it took for the recommendations to render, and so on and so forth. The beauty of this implementation is that the services do not need to be custom coded to be instrumented. Nor do you need to be watching every entity directly to be able to extrapolate health and performance data between services. The OTel framework is already implemented in multiple programming languages and just needs to be enabled and configured. In fact, many OTel-aware collectors do this automatically. This can be especially useful when dealing with auto-scaling groups, like the web front end, which might be 1, 5, 10, or even 500 individual services providing the same function. All right, I can see many of you are fidgeting in your seats, and I know exactly what you're thinking. What happens if not all of my infrastructure, not everything in IT is a microservice, is part of a container, is built like this? What happened to all the stuff about my routers and switches and servers and services, the stuff I care about at my branch offices or my self-hosted data centers? You don't have to worry about that. For the purposes of today's discussion, we are going to speak specifically about the SolarWinds solutions. If you have your own self-hosted traditional monitoring already implemented, all you have to do is cloud connect that with the SaaS-based solution and get full observability. In the event that you don't have that, but you do have branch offices or data centers that you own and operate, then you can use network and infrastructure observability to act as essentially a proxy and pull that traditional monitoring data and inject it into the observability solution. So you'll have all your traditional monitoring and your observability information all in one location. Okay, I know we're short on time, but I want to hammer home one thing to you. Observability data is better than traditional monitoring data. And hopefully what I've given you in this class will enable you to have better discussions as your organization moves to an observability-first solution. I encourage all of you to join the DevOps Discourse community group on THWACK. Post your questions there. Go ahead and try a trial of SolarWinds Observability. And we're still missing papers from at least 10 of you. So they need to be on my desk by Monday. That's all we have for today. Next week, AI Ops, reads chapter 7 and 8. And we'll continue the discussion then. Dismissed.